Right, children. We are starting with the first chapter of your class 11 syllabus. Chapter is some basic concepts of chemistry. I'll take up such simple things. You'll please don't mind. At times you will even wonder how come such simple topics are being taught in 11th standard. Everything is a part of your syllabus. Everything is a part of your syllabus. First of all, what is chemistry? Since we have started proper subject chemistry in 11th standard, we should know what is chemistry. Madam, chemistry is that part of science, that branch of science which deals with composition, structure, and properties of matter. Composition, structure, and properties of matter. So basically, we are concerned with these three things in chemistry. Composition. What is the meaning of composition? If I say water, composition means what are the elements present in this compound and what is the percentage by mass of every element present in that compound. That is called composition. Then I said we study about structure. Structure means how are these three atoms arranged, bonded to each other in the molecule of water. Are they bonded like this? No, this is wrong. Are they bonded like this? Yes, this is correct. But is the bond angle 180 degree? No, this is not 180. Bond angle is something like this. This bond angle is 104.5 degree. So that is the meaning of structure. We study about composition, we study about structure, and then we study about properties of matter. Next, right on the heading, matter. Matter, you all know what is matter. Anything which occupies space, anything which occupies space, comma, has mass, and can be felt by at least one of the five human senses. One of the five human senses is called matter. See, you will have the actual feel of chemistry after 2 or 3 classes, right? You know, there are 5 human senses: sense to see, touch, smell, taste, and hear. So any matter should be felt by one of these, at least one of these 5 human senses. And it should occupy space and it should have mass, right? For example, pen, chair, book, apple, anything. All these will come under matter. Continue. All matter is made up of atoms and molecules. Made up of atoms and molecules. Every substance has a characteristic set of properties. Characteristic set means typical set of properties which are of 2 types. Number 1, physical properties. Make it a habit to underline each and every topic, because this heading of the topic will use in the sentence as well. So that will take a few seconds. See, there are 2 types of properties of any substance. One is physical properties, the other will be chemical properties. Remember, when we study any physical property of the substance, of the matter, substance does not undergo any chemical change. Like if you smell something, it remains that particular substance. If I wait a minute. If we see the color of any substance, that substance chemically does not change. But when we study chemical properties of the substance, chemical composition of the substance changes. So these are two types of properties. So first is write down physical properties. Are those which do not involve any change in chemical composition, of the substance, any chemical change of the substance during its study. For example, color, smell, density, MP, melting point, BP, boiling point, etc. So when we study these properties, let's say we determine boiling point of water, water will remain water, right? Chemically, it will not change. So similarly, when we find out a density of the substance, melting point or boiling point or refractive index of the substance, chemically substance does not change. So study of these properties is nothing but study of physical properties. Number two, chemical properties. Chemical properties are those which involve change in chemical composition of the substance during their study. For example, combustion. You burn anything, it's a chemical change. Oxidation, reduction, etc. So they're all chemical properties. Substance will undergo a change in its chemical composition. Now, write down classification of matter. We'll take up two types of classification. First is physical classification. Physical classification. That on the basis of this, something you all know. On the basis of physical state, matter can be classified into solids, liquids, and gases. Solids, liquids, and gases. This classification is based on can anyone tell me what is the basis of physical classification of matter into solids, liquids, and gases? Why is one substance a solid, the other is a liquid, and third substance is a gas at room temperature? What is the basis?
How their molecules and atoms are arranged.
Sorry?
On the basis of how their molecules and atoms are arranged.
Okay. Okay, write down. This classification is based on intermolecular forces. So if force of attraction between particles are strong, very strong rather, substance is likely to be solid. If attractive forces between sorry, if attractive forces between particles are very weak, then it is likely to be a gas. And if attractive forces are of intermediate range, it's likely to be in the liquid state. Continue. All three physical states are interconvertible into each other. One physical state can be converted into another. If you think of water, water exists in the liquid state, exists in the solid state, exists in the gaseous state as well. So at different temperatures, same substance can exist in three different physical states. And at home also, you might have seen water exists in three different physical states. So again, I'm repeating what I'm teaching you today. Almost nothing is important from examination point of view, but is a part of your syllabus. Second classification, B part. Now this you'll have to note down from the board. Chemical classification. Now this you'll have to copy from the board. In chemical classification, we classify matter into two categories, pure and impure. If I say what is a pure substance, sometimes sometimes if the topic is very easy, it is difficult to explain it. If I say what is an impure substance, you'll probably say, some of you will say, pure is pure. See, one is pure, the other is impure. Pure means all particles are alike. All particles are alike. They are of same type. Naturally, in case of impure, two or more different types of particles. So impure substances have two or more different types of particles. And impure matter, impure substance is also called a mixture. So oblique mixture. Pure substance can be further divided into two categories: elements, compounds. Right? Elements are pure, compounds are pure. Similarly, impure, that is mixtures, can be divided into two categories: homogeneous and heterogeneous. One is homogeneous and the other is heterogeneous. Now we'll write about what are elements, what are compounds, what are mixtures, and what are homogeneous and heterogeneous mixtures. So write on the heading, element. Element. You know, hydrogen, nitrogen, oxygen, fluorine, iron, they're all elements. But how do we define them? That an element, it is that substance, which is made up of same type of atoms. So all the atoms present in the matter are same type, then we say it is an element. It cannot be broken down into simpler substances For example, save time and write symbols only. For example, H hydrogen, N nitrogen, Fe iron, etc. Next heading, compound. Compound. You know, CO2, carbon dioxide, is a compound. Any compound will be made up of two or more different types of elements. They are chemically united, chemically combined together. When I say chemically combined together means there is bond formation between between atoms of different elements. And these atoms present in the compound, they cannot be separated from each other by physical method. Like if I filter carbon dioxide in the liquid form, carbon and oxygen cannot be separated. If I evaporate liquid carbon dioxide, carbon and oxygen present cannot be separated from each other. So they cannot be separated from each other. Moreover, properties of the compound are entirely different from properties of elements which are present in the compound. So these are some very easy, simple points that are compound. It is that substance which is made up of two or more different elements chemically combined together. As I said, chemically combined together means bonded. Chemically combined together in a fixed ratio by mass. Fixed ratio by mass. Properties of a compound are altogether different from the properties of elements present in it. These elements present in the compound cannot be separated from each other by physical methods. If I say by physical method means without any chemical reaction, they cannot be separated from each other. For example, I'll give one example in which all the points will be justified. For example, water contains H and O, hydrogen and oxygen, in 1:8 ratio by mass. 1:8 ratio by mass, and they cannot be separated from each other by physical methods like filtration, evaporation, etc. So without chemical reaction, hydrogen and oxygen present in water cannot be separated. Continue. At room temperature, make it a habit to write T for temperature. At room temperature, hydrogen and oxygen are gases, while water is a liquid. Right? This is the difference in physical property, that is the physical state. Hydrogen and oxygen gases, while water is a liquid. Also, hydrogen is combustible. Hydrogen burns very quickly. Combustible. Oxygen is a supporter of combustion. It helps in burning, support of combustion. Whereas water is used to extinguish fire. Water is used to extinguish fire. So this is the difference in properties. Again, hydrogen and oxygen gases at room temperature, water is a liquid. Hydrogen is combustible, oxygen is a support of combustion, but combination of the two, that is water, is used to extinguish fire. Next heading, mixture. Mixture. If we mix sand and sugar, it will be, as I said, mixture. If we dissolve sugar in water, that is also a mixture. So you dissolve any amount of sugar or any amount of salt in water, it will be a mixture. And from that mixture, from that solution, if you evaporate water, then sugar or salt will be left behind. And those water vapors after evaporation, they can be condensed. So water can be obtained, sugar or salt, that can also be obtained. It means we can mix them in any ratio by mass. Number two, constituents of the mixture, they can be separated by physical methods. Now, as far as properties are concerned, properties of the mixture are intermediate between properties of components, that is substances which are mixed together. I'll give an example, right? Sugar is sweet. Sweetness is the property. Sugar has some sweetness. Water has a flat taste. Flat taste means no taste. When it dissolves sugar in water, the mixture obtained, that is solution, is neither as sweet as pure sugar, nor it is as flat in taste as pure water, but its sweetness is intermediate between sweetness of pure sugar and sweetness of pure water. So properties are intermediate, can mix in any ratio by mass, can be separated from each other by physical methods. So these are main points. Pattern mixtures are those which are made up of two or more different elements or compounds mixed together in any ratio by mass. In any ratio by mass. Its properties are intermediate between properties of substances which are mixed together. Constituents of the mixture can be separated from each other by physical methods. Without any chemical reaction, we can separate them. Mixtures are of two types. A part, homogeneous mixtures see, if we dissolve some sugar in water, let us say this is the beaker, I dissolve sugar in water. After dissolving, if I take some solution from here and taste, it will have some sweetness. if I take out from here and then taste, sweetness, degree of sweetness will be same. It means composition of the mixture is same throughout, then it is called a homogeneous mixture, and homogeneous mixture are also called solutions. But if we mix sand and sugar, if we mix sand and salt, even if we grind it, but when we view it under a powerful microscope, at different places, size of sugar and sand particles will be different. It means composition will not be same throughout. That will be called a heterogeneous mixture. So write down number one or A part, homogeneous mixtures. Write down are those whose composition is same throughout. For example, salt plus water, alloys. Steel is an alloy, brass is an alloys, etc. They're also called solutions. They're also called solutions. See, it's very easy to understand that salt dissolved in water, sugar dissolved in water is a solution. But if I say alloys are solutions, if I say steel is a solution, brass is a solution, how come they are solutions? See, to prepare alloys, solid metals are mixed. The mixture of these solids is then strongly heated so that the mixture melts. On melting, naturally, it becomes a homogeneous mixture. After that, this liquid part is cooled and this becomes a solid alloy. So alloys are homogeneous mixtures. They are nothing but solutions which have been converted into solid state. Number two, a B part, heterogeneous mixtures. Heterogeneous mixtures are those whose composition is not same throughout. Not same throughout. For example, NaCl plus sand, sodium chloride plus sand. As I told you, you grind the mixture as much as you want, but it will never be a homogeneous mixture. Composition will not be same throughout. Next topic. Now, since we are talking about mixtures, now the next topic will be how can we separate constituents of a mixture, whatever substances are mixed to prepare a solution, how do we separate them by physical methods? We studied some physical methods for their separation. Write on the heading. Heading is separation of constituents of a mixture. Separation of constituents of a mixture. That constituents of mixtures. रेहान बेटा माइक ऑफ करो अदरवाइज डिस्टर्बेंस होगी सबको. Constituents of mixtures can be separated by physical methods. Some of these methods are given below. Number one, sedimentation and decantation. If I'm not wrong, you might have heard of this term sedimentation and decantation somewhere in 7th or 8th standard. Can you give me an example where we can separate two substances present in the mixture by sedimentation and decantation?
Sand and water.
Sand and water. It means main thing is this method can be used when one substance is solid, the other is liquid. I hope you agree to it. One is solid and the other is liquid. But can we separate this? Can we use this method to separate sodium chloride from water? Sodium chloride is a solid and water is a liquid. Can we use this method? Answer is no. Then what is the main condition that we can separate a solid from a liquid by using this method?
It should be unsoluble.
Solid should be?
Unsoluble.
Yes, it should not dissolve in the liquid. Then only we can separate. Okay, then one thing more. If we take sawdust, what is sawdust? When we cut wood, that powder obtained is called sawdust. Sawdust is solid. Water is a liquid. If I add some sawdust to water, can I use this method? Sawdust is insoluble. Now tell me, what is the next condition?
The particle size should be smaller, like should be
Particle
greater
should
than
be-
1 and greater, like between 1 nanometer to 100 nanometers.
No. That will come in solutions, not in this case. Those, sawdust is so light, it will float. And sedimentation means settling down. When will the solid settle down? When its density is more than the density of liquid. So conditions are, one should be solid, the other should be liquid. Second condition, solid should be insoluble in the liquid. And third condition is density of the solid should be high so that it settles under gravity. So all will combine together in just one sentence. So write down, this method is used to separate an insoluble solid of high density from a liquid. Right? Everything has come in one sentence. For example, sand plus water. Sand plus water. Second method, filtration. Filtration. See, in every household, this method is used. Like when we prepare tea, we filter it. Again, in this case, we remove one solid from the liquid. This solid is again insoluble in the liquid. And third condition is flexible. This solid may be of high or low density. It means this method can be used to separate sand and water, which could be done by sedimentation and decantation as well. The same mixture can be separated by filtration also. Filtration can also be used to separate sawdust from water. Sawdust and water could not be separated from each other by sedimentation and decantation. But this method can be used, filtration can be used to separate sawdust from water. It means conditions are, one should be solid, the other should be liquid. Number two should be insoluble. And third condition is density of the solid may be high or may be low, does not matter in this case. But one thing, for separation, we need a medium, we need a what we call filter paper. And the size of pores of filter paper should be smaller than size of pores of filter paper should be smaller than the size of solid particles. Now, liquid which is obtained after filtration, that is called filtrate. I'll write on the board. And the solid which is collected after filtration, like tea leaves which are obtained in the sieve after filtration, that is called residue. Right on. This method is used, filtration, right? This method is used to separate an insoluble solid of high or low density from a liquid by using a filter paper. For example, sawdust plus water, sand plus water, etc. Solid left on the filter paper is called residue, while the liquid collected is called filtrate. So the tea which we drink is filtrate, and tea leaves which are left on in the sieve, that is residue. Next method, third method, gravity separation. Gravity separation. Gravity is related to, here it is related to density. See, if we have mixture containing two solids, particles of one solid are very light, particles of the other solid are heavy. If we drop the mixture from a height and we keep a fan here, right? We drop the mixture from the height and we keep a fan here. As we start the fan, what will happen? Lighter particles will be blown away and heavy particles will fall straight down. It means this method is based on difference in the density of two difference in the density of particles of two substances which are mixed together. And for the separation, we need a medium. In this case, the example which I gave you, the medium used was air. Similarly, if you remember in 10th standard, you might have studied in metallurgy. There was a chapter on metals and non-metals. You might have studied about hydraulic washing, separation of ore from gangue, matrix, sand particles. So with for the separation of these two, we use, does anyone remember what do we use? No, we use water. See, ore is crushed. It's almost in the powder form. This crushed ore is kept here, and then with the help of water, particles which are lighter, they will be carried away. Heavy particles will be left behind. Ore particles are heavy, they will be left behind, and sand or gangue or matrix particles, they are lighter, they are carried away. This is called hydraulic washing. This is one of the methods of concentration of ores. So write down gravity separation. This is used to separate solids of different densities. For example, separation of grain from husk. Separation of grain from husk. See, in villages, after the crop ripes, it is, let us say we talk about rice or wheat, they thrash it. Then they use the method which I said, with the help of fan. They don't even need a fan. Natural air will blow away husk and grain particles will fall straight down. So this is the method based on difference in density of particles. Next, fourth method, from the name itself, it will be clear how do we separate. Fourth method is magnetic separation. Magnetic separation. And used to separate a magnetic substance from non-magnetic substance with the help of a magnet. With the help of a magnet. For example, sand plus iron filings. Iron filing means very, very small pieces, almost sort of powder, you can say, very small pieces of iron. Sand and iron filings, so they can be separated from each other by using magnet. Next method, sublimation. I'm sure you all know what is sublimation. Just give me an example of a substance which undergoes sublimation.
Ammonium sulfate, ammonium crystals.
Ammonium, not sulfate, ammonium chloride. Well tried. Ammonium chloride. Naphthalene, good. Iodine, camphor, benzoic acid. So there are many substances, many elements and compounds which undergo sublimation. They directly change from solid to the gaseous state on heating and directly change from gaseous to the solid state on cooling. But how is this method of sublimation used in purification? First you write, then I'll tell you with the help of an example, I'll explain how this method is used for separation. Right now, sublimation. It is the phenomenon of direct conversion of a solid in a gas on heating and gas into solid on cooling without involving the intermediate liquid state. Without involving the intermediate liquid state. Solid collected after sublimation. Solid collected after sublimation is called sublimate. For example, ammonium chloride NH4Cl, camphor, iodine, naphthalene undergo sublimation. Mixture of NaCl plus NH4Cl, ammonium chloride, can be separated by filtration. just look at the board. There's no need to write anything. If you want at maximum, you can draw the diagram. This diagram will be self-explanatory how the method is used. See, diagrams in chemistry are not important at all. So diagrams which I draw will not be, good to look at. So this is the China dish. In this China dish, I take the mixture of ammonium chloride plus sodium chloride. I cover this China dish with the help of a paper which has very small holes in it. We call it perforated paper. Perforated paper means paper with holes in it. You can see how beautiful is the burner which I've drawn, right? Triangle is burner. This is the inverted funnel, you can see. And this is cotton plug, right? I hope diagram is clear. See, when we heat the mixture of ammonium chloride and sodium chloride, ammonium chloride will directly change from solid to the vapor state, gaseous state. These gaseous form, that is vapors of ammonium chloride, will pass through holes of perforated paper. Now, these vapors of ammonium chloride, when these vapors come in contact with the cold surface of funnel, see, funnel is far away from the burner. So surface is cold. These vapors of ammonium chloride, they will directly change from gaseous to the solid state. And these solid crystals of ammonium chloride, they will stick to the walls of a funnel. So this is what? Nothing but sublimate. So sublimate is nothing but ammonium chloride. And sodium chloride will be left behind in the China dish. Now, the question is, why do we use perforated paper? If we do not use this paper at all, then what will happen? One problem is heat will be transmitted to the funnel, surface of funnel will become hot, and this condensation of vapors, rather sublimation, gaseous to solid state will not take place. Number two, as the time passes, these crystals will grow, they will become heavy. When they become heavy, they fall down. And if they fall down, they will go back to the China dish. So they will stick to the surface so that they can be separated. So this is sublimation. Next method. Three more very simple methods. Next is distillation. Distillation. This is used to separate those substances of the mixture whose boiling points have a difference of more than 30 degrees centigrade. So difference in the boiling points of constituents should be high. That is, it should be more than 30 degrees centigrade. Then only distillation can be used. So one component whose boiling point is very high, that will be left behind in the flask. The other will be collected in the liquid form. See, if you want to separate sodium chloride from water, Please listen to my question and answer. If you want to separate sodium chloride from water, filtration we cannot use. Can we use evaporation or not? Yes or no?
We can use
We can
evaporation.
use.
We can use. No, we cannot use. Separation means we have to obtain all the constituents of the mixture. When we evaporate, we do not collect water, we do not condense water vapors. Evaporation means we do not condense water vapors. It means we'll obtain solid sodium chloride but will not obtain water. We can use the method of distillation. Water vapors will be condensed and liquid water will also be obtained. Next method, fractional distillation. Fractional distillation. I'm sure you have heard of this technique, fractional distillation. Can you tell me where is fractional distillation used?
For water and what, like oil,
In?
like liquids that have different densities, I think. I'm not entirely sure.
This is used in petroleum industry. Petroleum industry. Fractionation. Petroleum has different fractions. You're using petrol, diesel, CNG, PNG, coal tar, then kerosene. They're all fractions of petroleum, and they're separated from each other by fractional distillation. In this method, boiling points of components, they are close to each other. So normal distillation cannot be used. This is a special technique called fractional distillation, which is used for this purpose. Fractional distillation. This is used to separate those substances whose boiling points have a difference of less than 30 degrees centigrade. Less than 30 degrees centigrade. For example, fractionation of petroleum. Fractionation of petroleum. Now, for the last method, I'm asking you something. Suggest me what should I do. Let us say I have a mixture of sand and sugar. I want to separate sugar from the sand. What should I do?
Dissolve in water.
Dissolve
Very
both
good.
of them.
After I dissolve in water, what do I do?
You make a saturated solution of sugar. So the saturated solution, like you heat it so that this sugar dissolves completely in water, and sand will not dissolve in water.
Yes, that is, we'll use the method of filtration. We get residue as sand and solution will be sodium chloride dissolved in water. Now, how do I get sodium chloride or sugar from that solution? Now I use the method of evaporation or distillation.
Since we only need salt, probably evaporation.
You
But
can
if we
use
need water,
evaporation.
Yes, yes. So we can use either of the two, evaporation or distillation. Both will be fine. Now, in this method, why did we use water? What is the role of water? Water has taken out sodium chloride from the mixture. Look at the action. Water has taken out sodium chloride from the mixture. Water has extracted out, removed. So this method is called extraction. So write down last method, extraction. This method is used to separate that substance from the mixture which is soluble in a particular solvent, while other substances of the mixture are insoluble. Other substances of the mixture are insoluble. For example, NaCl plus sand by using water. NaCl plus sand by using water. So that's all, children. That's all for today's class. Let me first of all stop recording.
Thank you, sir.
Thank you, sir. Bye, sir.
Right.